Hello everyone, welcome to the chapter Classification of Elements and Periodicity in Properties. Today we will be taking a look into the competitive part of it. What kind of questions that we can expect in examination? There are competitive exams that what we are focusing here is going to be the KCT, Karnataka CT, JEE, Joint Entrance Examination and NEET. When we take a look into KCT, we are going to have 60 questions. But the good thing is that there are no negative markings. So therefore you can attempt all the 60 questions without any fear. While when we take a look into JEE part or a NEET part, what will happen is per question is going to be governed with 4 different options. Of course, one option is going to be correct or more than one option can be correct. In such conditions, what will happen is if we are giving a correct answer, we will be awarded with 4 marks, and every incorrect answer that we give, 1 mark will be deducted, right? So if you are in a doubt, it's better to just proceed without answering that particular question. Now we shall see certain sample questions with respect to this chapter. Starting over with the first question: which of the following group of elements is assigned with 0 electronegativity? Electronegativity. We have already completed the concept of electronegativity. That means the ability of an atom to drag the shared pair of electrons between the 2 combined atoms, right? So observing the conditions, the first one, noble gases. Now in noble gases, what is the condition here is the electronic configuration plays an important role. So when we take a look into the electronic configuration, this particular gases already have a completely filled outermost configuration as ns2 np6. First condition, it is not going to drag any electrons towards itself. While alkali metals have a tendency as electronic configuration as ns1. Here it is becoming as ns1. It is not going to accept the electron, rather it can freely give an electron. Correct. So therefore alkali metals can easily give an electron rather than accepting the electron. They are not going to pull the electron, rather they can give the electrons. While alkaline earth metals, again a condition of ns2. That means completely filled orbitals. Of course, rare earth metals, it is a metal again, so therefore condition is that it is going to give electrons, it is not accepting the electrons. Correct. So the only one which can suit for our answer right now is going to be the noble gas, because of its completely filled outermost orbital. So therefore the noble gases are assigned with a value of 0 electronegativity. Please remember this point. The group of elements which are assigned with as 0 electronegatives are going to be the noble gases because of their completely filled outermost orbit. Coming forward with the second question: electropositive or metallic character. Now they are asking us how does a metallic character is going to vary in a periodic table. So we need to understand that as we go from the left to the right, towards the right we have gases at the end, right? So therefore metallic character, of course, it's going to decrease as we go from the left to right. Metallic character, of course, it's going to increase as we travel from the top to the bottom. So taking that into consideration, let us see. Increases in a period. No. Metallic character decreases as we travel from the left to right in a particular period. So we cannot accept that. Going forward, decreases in a group. Again, it's the exactly opposite. What will happen? As we travel from the top to the bottom, metallic character goes on increasing. Okay, so again, this is not accepted. Decreases in a period, yes. Increases in a group, yes. So therefore our answer is option C, right? So electropositive character or the metallic character increases as we go from the top to the bottom in a group and decreases as we go from the left to the right in a periodic table. Now, coming towards the question number 3. Question number 3 is the ionization potential does not depend upon. Now, first, ionization potential, amount of energy that is required in order to remove the outermost electron from an atom which is taken in a neutral gaseous state. Right? So, now what we are trying to do is we are trying to remove the electron out. So, let us say, as the atomic size increases, attractive power decreases. So, therefore, the outermost electron can be removed very, very easily. So, therefore, first one, yes, it depends. They are asking which does not depend, but it depends upon atomic size. Second one, type of electron. Now, type of electron in a sense, like S block electrons, P block electrons, F block electrons, right? So, what will happen? S orbital electrons are very close to the nucleus. After that comes is the P orbital electrons. After that comes is the D orbital. After that comes is the F orbital. So, as the orbit shifts from S to P, from P to T, from T to F, the distance from the nucleus goes on increasing, and therefore the outermost electron can be removed very easily. Therefore, it depends upon what is the type of electron that we are focusing. Therefore, yes, it depends. Nuclear charge, of course, we are speaking with respect to the attractive power. More the nuclear charge, more is the attraction. More is the attraction. Electron is held more comfortably or strongly towards the nucleus. So, therefore, more amount of energy is required in order to remove this electron out. Right? So, therefore, it also depends upon the nuclear charge. Only one thing that does not depend upon is what kind of bond is present in the crystal lattice. So, therefore, our answer lies here. Ionization potential does not depend upon the type of bonding that is present in the crystal lattice. Right? Now, coming towards the next one, and that is in the long form of periodic table, the transitional elements are placed in. Now, if you observe the periodic table carefully, the first two groups, S block, the last from the 13 to the 18, what we are going to have is going to be the P block section. Down are the F block. The middlemost section of the periodic table is going to contain the transitional elements. So, therefore, the middle section of a periodic table is going to be the P block elements. So, these are the four. Coming towards the question number 5, what we have is the valency of noble gases in general is. Let's try to understand. They are asking about the valency. That means what is the capacity of a particular atom to form the bond. How many bonds that particular atom can form. Now, it depends upon the valence electrons, how many number of the outermost electrons are there, whether it's complete or not. Okay, so in that case, when we speak about the noble gas, they are asking us the valency of the noble gas. But noble gas has an electronic configuration, general electronic configuration as ns2 np6. That means the outermost orbit is completely filled. It neither wants to give electron, it neither wants to take in the electron. Therefore, it is not going to form any bond. It is not going to give any electrons, neither it is going to accept any electrons. Therefore, no bonds can be formed by the noble gases. Therefore, what we can have is the option over here as 0. As we had an option as 0, 1, 2, 3. But 0 is the answer, as it cannot donate or take any electrons, neither it can combine. Therefore, noble gases in general have a valency of 0. Coming towards question number 6, as which of the following have the highest electron affinity value? Now, we have spoken about the electron affinity in a sense. When an electron enters into a system, how much amount of energy that can be released. It also depends upon the size of an atom. Smaller size, first let's look at the smaller size. The smallest size actually in this case is going to be fluorine. right? Now, what will happen is, according to the sizes, if I see, it is going to be the first as fluorine, right? So, fluorine and chlorine, these particular things have a tendency of accepting the electrons, while the alkali elements which we have over here, that is a sodium and potassium, are ruled out because these are electropositive element. That means it is going to give electron, it's not going to accept the electron. Okay, so therefore things which are ruled out over here is going to be sodium and potassium. Now we need to decide between the fluorine and chlorine. Now if we speak about the atomic size, smaller atomic size, that means greater attraction to the outermost coming electron, right? So the moment the electron comes, attractive power is going to increase, it is going to accept the electron, energy is going to release, but by that thought we would say that as a fluorine, but this is not the answer. There is an exception between chlorine and fluorine. It is because the fluorine has very small and compact size. The electrons what we have in the fluorine are going to be condensed. They are condensed, they are compressed. Therefore, the electron charge is compressed in a very small region. Therefore, whenever an electron tries to come in, it has been repelled by the dense electron cloud. As a result, what will happen? The electron will try to enter inside, but it is repelled again. Okay, therefore, the attractive power in this case between the nucleus and the incoming electron is decreased. Thus, the energy is not as that much as what we expect. Therefore, the answer is not fluorine. It is because of the very small atomic size, greater electron density region, the incoming electron is repelled, attractive power decreases, therefore electron affinity value decreases. The correct answer in this case is going to be the simple fluorine, right? So what we have is which of the following has the highest electron affinity value, and that is going to be our fluorine. Coming towards the next one, question number 7 says that alkali metal in each of the period have. Now, a period starts with the alkali metals. So therefore, what are the characteristics of alkali metals? First characteristic is it is going to have the biggest atomic size. So as we go from the left towards the right in a periodic table, the atomic size goes on shrinking. It goes on becoming smaller and smaller, right? So now let's see what will happen. Bigger size, but option 1 says that it has the small size, so therefore this option is ruled out. It's wrong. Lowest ionization enthalpy. Now let's correlate how ionization enthalpy is going to be related with the size of an atom. What we know is if the size becomes larger, the distance from the nucleus to the outermost electron increases. Therefore, we can easily remove the outermost electron. Therefore, the amount of energy that is required to remove outermost electron is called as ionization enthalpy, and it is going to have the lowest ionization enthalpy. Of course, highest ionization enthalpy is a contradictory, exactly opposite. Highest electronegativity. Now, we have been discussing the same thing, that is an alkali metal. It is not going to accept the electron, rather it has a tendency to give the electron. So therefore, there is no question, there is no doubt about the electronegativity. So our answer sticks with over here as the lowest ionization enthalpy. Coming towards the next one, what we have is the question on the shielding effect, or it is also called as a screening effect. Screening or shielding, both of them are same. Now, taking a look into the question, screening effect of the inner electrons of nucleus causes decrease in ionization enthalpy, increase in ionization enthalpy, no effect on ionization enthalpy, and the final option says increase the attraction of the nucleus to the electrons. Now, screening effect. Now, what is a screening effect? Screening effect occurs because of the inner electrons. So let's say this is the nucleus. This is the first shell, this is the second shell, and let's say this is the third shell, right? Now, in the first shell, we have 2 electrons here. 1, 2, 3, 4, 5, 6, 7 and 8. 8 electrons, that means neon. Therefore, let's say that we have 2 more electrons. Now, what will happen? The shielding effect or screening effect, these electrons, what they will do? They will see that they are going to surround the nucleus very well from all the sides. Thus, it decreases its attractive power to the outermost electrons. The outermost electrons will feel lesser attractive power from the nucleus. As the outermost electrons will feel less attractive power from the center of the nucleus, therefore we can easily remove this particular electron, right? So it is indirectly affecting our ionization enthalpy. Therefore, greater the shielding effect, lower is the ionization enthalpy. So therefore, what it happens is, as screening effect of inner electrons of nucleus causes, that is, decrease in ionization enthalpy. Going forward with the next question, the second ionization energy is highest form. First one is magnesium. Now they are asking us about ionization enthalpy, right? That means how much amount of energy is required to remove the outermost electron. It's quite logical. We'll observe first the options: magnesium, aluminium, sodium, silicon. Now, the number of electrons in the outermost shell in the case of magnesium are 2. In the case of aluminium are 3. In case of sodium, the outermost is 1. In the case of silicon, it's going to be 4. Okay. Now, what will happen is, if we want, we can remove these 2 electrons and magnesium is going to be formed in the form of Mg plus 2. Aluminium can easily lose 3 electrons in order to form Al plus 3, so that the outermost configuration is going to be as a completely filled case. But in the case of sodium, when it loses 1 electron, now we know the atomic number of sodium is 11. So 1s2, 2s2, 2p6, 3s1. This is a condition, right? So what will happen in this case is, sodium can lose this 1 electron. As it loses this 1 electron, this is a condition what is going to be formed. So now what is going to happen is, ns2 np6 condition is formed. That means the outermost orbit is now completely filled. As the outermost orbit is completely filled, it makes it stable. Now it cannot afford to lose any electron. Thus, if you want to remove this particular electron, that is the electron from this condition, more amount of energy is expected in that case. So therefore, the answer lies with the condition C. That is, the second ionization enthalpy is going to be the greatest for sodium. So the next question is, among the following, take the odd one out. Now, if we observe it carefully, in the first case, that is the calcium, strontium and barium. Second case, lithium, sodium, potassium. Third case, chlorine, bromine and iodine. It forms the Dorvanius triads. These 3 go along with the Dorvanius triads, and the examples we have seen at the normal theory class. Now, the odd one over here is the iron, cobalt and nickel, which does not follow the Dorvanius triad. Okay, and it is in the same period. These all 3 elements are occurring in the same period, and therefore it is not going to follow the Dorvanius triad. The next case, among these, which one does not match? Now, in the first case, they have asked us sodium alkali metal. Yes. Helium is a noble gas. Perfect. Nitrogen, nitrogen family, correct. Now Fe is not an inner transitional element, so therefore Fe is not an inner transitional element, so therefore it does not match. It is not going to match in this case. Therefore, the answer is B over here. Arrange these elements in increasing order of their atomic size. Atomic size, they are asking us about halogens. So, halogens. The halogens starts with first one, smallest one, fluorine, chlorine, bromine, iodine. So, let's observe the particular option starting with fluorine, ending with iodine. Okay, fluorine, iodine. So here is an exactly opposite one. So therefore, the answer is C. Fluorine is the smallest, followed by chlorine, followed by bromine, and finally iodine. Iodine is having the biggest size. Question number 13. According to the Mendelev's periodic law, the property of element are the periodic function of. Now, let us observe all these. Atomic number, modern periodic table, okay, or modern periodic law. So therefore, no. Density, not possible. Atomic volume, the curve which was given by Lothar Meyer. So right now we are not dealing with the Lothar Meyers. Right now we have is the Mendelev's periodic law. So therefore this is not an option. What remains with us is the atomic weight. So we know about Mendelev's periodic law, which says that, yes, it says that the properties of elements are the periodic function of their atomic weights. Right? So coming forward with the next, that is the 14th question. The element with the highest first ionization enthalpy. They are trying to take out the first electron. So in that case, we need to see that the outermost shell is completely filled and the atomic size is very small. This is a condition. So hydrogen, no, because it has an S1 condition here. Radon, no, because it's larger enough compared to that of helium. Fluorine, of course not. So smallest one over here with the completely filled outermost shell, that is S2 configuration, is helium. So therefore, amount of energy that is required in order to remove the electron is going to be high in the case of helium. So therefore, helium is a particular element with the highest ionization enthalpy. Coming towards the next question, that is to match the following type of question, wherein we need to match the components of list 1 and list 2. Let us observe the question. Match the list 1 with the list 2 and then select the correct answer from the codes that are given. Okay, so first thing, the element with the half-filled orbital. Let's see. Chlorine, it requires one more electron to fill its outermost orbital, so it's not the answer. Nitrogen, yes. Nitrogen has P3 type of configuration and therefore nitrogen is the answer for first one. So therefore I need to first find the particular condition wherein I have AQ as a code. So where is the code AQ? 1, no, 2, no, 3. AQ, yes. First condition here is satisfied. Here is an AR. So naturally we have got our answer. So going forward with the next one, the alkali metal, B is going to be S. So yes, B, S. Next one, high electron affinity value. The element with the highest electron affinity value is going to be the chlorine. So therefore, C is P, right? So the last one, the one with the noble gas, that is the noble gas element, that is the xenon. So R, so D, R. So therefore, our answer here lies with the option as C. So I hope that you have understood today's simple question that what we can expect to enhance. as we start our actual studies. Thank you.